This video will explain you the methodology for estimation of emission rates from road traffic. For estimating on-road emissions, I used CMEM model, which means Comprehensive Modal Emission Model. That is a microscopic level emission model developed by University of California, Riverside Drive. The purpose of this video is sharing the knowledge how to work with CMEM emission model. I prepared this presentation while I am working on EcoDrive project on behalf of Carleton University. CMEM is a microscopic emission estimator because there is a facility to import speed trajectories every fraction of seconds. Speed or velocity trajectories represents the on-road vehicle activities that can be imported from Traffic Microsimulator VSIM. The speed trajectories can be imported by downloading GPS-enabled instrumented vehicle data in GIS software. First thing first, you need to save your file. Go to File, then Save As. Write any file name and click on Save. As you can see, CMEM contains 5 different tabs. Those are Activity, LD Vehicle, HDD Vehicle, Fleet and Growth. Activity means on-road vehicle activities every fraction of seconds. Description of light-duty vehicle and heavy-duty vehicles are available on LD Vehicle and HDD Vehicle tab. Finally, on-road vehicular fleet should be mentioned clicking Fleet tab. Click on Activity. You can create your activity file. Enter new activity file name and click OK. You can create your own activity file by clicking on row and column. Rename your column header from drop-down arrow. Vehicle activities are speed and acceleration of on-road vehicles in time intervals. This slide shows how to import activity data from either sources, from VSIM model or GIS software. Note that the import file should be text file. After import data, you can change column header by drop-down arrow based on data properties. This slide illustrates imported activity data from VSIM, whereas repetition of time represents the number of cars on road. Among velocity data, find the average speed. It is important to know the unit of speed and acceleration before importing into the CMEM model. On-road vehicle activities represents the speed trajectories from light-duty vehicle as well as heavy-duty diesel vehicle. By clicking on light-duty vehicle tab, you are able to change vehicle types and their specifications such as power, weight, engine displacement if necessary. You can also change calibration parameters such as fuel specification and emission coefficients. This slide shows how to change vehicle types with default values. Vehicle categories are listed on data. Load types of vehicles for your input. As an example, passenger cars can be classified with two-way catalytic converter or three-way catalyst. The gross vehicle weight of a light-duty trucks either less than 8,500 pounds or greater than that. Once you add all light duty vehicles, the next step is selecting heavy duty diesel vehicles. You are entitled to change vehicle specifications and engine specifications such as power and size of an engine in a particular type of vehicles. Moreover, CMEM models facilitates you to change fuel specifications based on local fuel properties. If you have local inspection maintenance programs database, you are entitled to change emission coefficients by clicking on emission tab under calibrated parameters. Under heavy duty diesel vehicle, click on test to change parameters of local climate conditions. Local climate parameters such as temperature, wind speed and directions are affecting on estimation of particulate matter from engine tailpipe as well as wear and tire friction. However, secondary pollutants such as nitrogen dioxide concentration can vary due to local climate condition. Similar to light duty vehicle, you can load your heavy duty diesel vehicle from default values by clicking on data. Heavy duty diesel vehicles are bus and trucks. Similar to earlier, you can change types of vehicles based on number of axle, emission control unit and year of manufacture of vehicle. The next task is providing VMT information to the model. Vehicle miles travel represents the fleet value, which means vehicles travel on road. Add all types of vehicle fleet composition. Note that the fleet data should input as fraction. Then click on calculate fleet. The question may come to your mind where the results will be used. The emission rates used to estimate air pollution concentrations. This slide demonstrates a snapshot of Kaline air quality model where emission rates are used as a composite emission factors in terms of grams per vehicle mile. The air quality models estimate on-road air pollution and pollution levels at any location surroundings to road. Therefore, the microscopic emission estimator CMEM provides emission rates as well as total emissions for different pollutants such as carbon monoxide, carbon dioxide, hydrocarbon and NOx. It is also possible to estimate total fuel consumption using CMEM model. I hope this video will be useful for you using the microscopic emission estimator CMEM. For emission estimator, I also have some other videos using US EPS MOPS. For more videos, you can subscribe to my YouTube channel, the link below. Thank you everybody.